Welcome to this channel. Please, if you are new, please subscribe, like, and share. Now, I want to take us through the application of differentiations. Now, number one, under this aspect, we'll be talking about the gradients. When you hear the word gradient, what does that mean? Gradient or slope. It means dy dx. Gradient or slope means dy dx. Now, when you hear the word coordinate, what does it mean? It means x and y. Coordinate means x and y. Now, let's take a look at these examples on the board. Now, they said the gradient of the curve y equals to 3x squared plus 11x plus 7 at the point P, coordinate xy is minus 1. Find the coordinate of P. You are looking for this. You are looking for x and y. I told you, they say the gradient of the curve. Anytime you hear gradient in the application of differentiation of calculus, so I go to differentiate, it means dy dx. That means I'm going to differentiate this. 3x squared plus 11x plus 7. Differentiation of this, that is 6x plus 11. And they said the gradient of the curve y equals to 0 at the point P is minus 1. That means minus 1. And I'm looking for coordinate xy. I'm looking for x. Let me get x from here. That will be 6x equals to minus 1. If I bring this one, minus 11. 6x equals to minus 12. All over 6, all over 6. S equals to minus 2. That means I've gotten x to be minus 2. Now, do not forget I'm looking for coordinates. That means I need to get y also. How do I get y? I know that y equals to this from the original questions given to me. Y equals to this. So I can get y like that. Anywhere I see x in these functions, I'll just substitute minus 2 in order to get my y. So that means y equals to 3 open bracket minus 2 plus 11 open bracket minus 2 plus 7. That means y equals to minus raised to power 2, that is 4. 4 times 3 is 12 plus 11 times minus 2, that is minus 22 plus 7. That means y equals to 12 plus times minus 22 plus 7. Y equals to 12 plus 7, that is 19. 19 minus 22, that is minus 3. So that means my y equals to minus 3. So that means the point P, coordinate of P, which is this that we are looking for, xy, it is minus 2 and minus 3. That is second one. I'll give you something like this. They say find the gradient of the curve. The gradient of the curve y equals to 2 root x minus 1 all over x at the point x equals to 1. X equals to 1. So they said we should find the gradient. Like I told us before we started, that anytime we hear the word gradient, it means the y dx. That means we have to define the gradient of the curve. We are looking for this derivative of this, the y dx of this. So that means if we want to differentiate this, 2 root x minus 1 all over x. That's enough gradient. So definitely 2, what is x? Root x means x raised to power 1 over 2 minus, I can bring this one up, become x raised to power minus 1. So what do? I'm going to use this power to multiply this. That is 1 all over 2 times 2x, and I will subtract 1 from this. So minus open bracket x. If I use minus 1 to multiply this, I have minus x and minus 1 because I will subtract 1 from power. So we are having 1 times 2, and that is 2x all over 2. Our xm is 2. 2 into 1, 1 times 1, 1. And 3 in 1, 2 times 1, 2. That's minus 1 all over 2. So minus minus, that is plus x raised to power minus 2. This cancels this. Actually, we have x raised to power minus 1 all over 2 plus, if I want this minus to go, that will be 1 all over x raised to power 2. The same thing applicable, I can apply for the negative index as you say. So I can also say 1 all over x raised to power 1 over 2 plus 1 all over x raised to power 2, which is also makes 1 all over root x, because this one makes root x plus 1 all over x raised to power 2. Now, when we have this, they now say at the point x equals to 1. At the point x equals to 1. Here, they did not ask us to look for coordinates. They said we should find the gradient. They now say that after we've gotten the gradient, our s equals to 1. So what we do is that 1 all over root 1 plus 1 all over 1 squared. That means root 1 is 1. Loving this is root 1 is still 1 plus 1 all over 1 squared is still 1. 1 all over 1, 1 plus 1 all over 1, 1. So the answer is 2. The answer is 2. Now let's take a look at now they said find the slope. Find the slope of the curve. Find the slope of the curve y equals to 2x squared plus 5x minus 3 at open bracket 1, 4. Coordinate of 1, 4. Now, if you see this, anytime you hear the word gradient, it can also be called slope. Gradient can also be called slope. So that means find the gradient or find the slope of the curve also means that you are finding you are differentiating this. So ddx, derivation of this, 2x squared plus 5x minus 3. So if I differentiate 2x squared, it's going to give me 4x. That means 2 times 2x, that is 4x. I'll subtract 1. 4x raised to power 1 is 4x. Plus differentiation of 5x is 5. Anytime you are differentiating number with coefficient, just that number. And differentiation of ordinary number is 0. So that means differentiation of this is this. That's what they asked us to find. Now say at this coordinate 1, 4. What does that mean? The first coordinate is always x, while the second one is y. That means anytime I see x, I'll substitute 1. That means 4 bracket 1 plus 5. 4 times 1, that is 4 plus 5. Our answer is 9. I do not need y in this case. I do not need any y in this case. So that is what they asked me to find. Let's take a look at another one. It said they find the point. Now come like this. Find a point on the curve. Point on the curve y equals to x cubed plus 6x squared minus 15x plus 1, at which the gradient at which the gradient is 0. At which the gradient is 0. According to the options that are here, we're going to be working towards the options. It says find the point on the curve where y equals to this at which the gradient is 0. When you hear the word point, that means it is xy. We're talking about that point is talking about the x and y on the curve. Now, at which the gradient is 0. They say at which the gradient is 0. That means they ask us to find this gradient. And they say when we now find the gradient will be equals to 0. And what is the gradient? It means differentiation. That means we are going to find the y-derivative of this. That means d dx, the derivative of this, s plus 6s minus 15x plus 1. So that means what is the differentiation of s cubed? That is 3s squared. You multiply 3 by this, you subtract 1. Plus derivative of differentiation of 6s squared. That is 12x minus 15. And this one is 0 already. Then I say that the gradient is 0. That means equals to 0. So that definitely we are going to factorize what is there. If I were you, I can reduce this because something can go in all of them. Over 3, over 3, over 3, over 3. 3 cancel 3. That means s squared plus 4x minus 5 equals 0. So you can now factorize it. That means if you factorize it, you are having minus 5s squared. So what are the two numbers that when I multiply them, they will give me this, and when I add them, they will give me this. So that will be plus 4x, or sorry, I can say plus 5x minus x. So if I multiply this, it will give me this. If I add it, it will give me this. That means I'm having s squared. I will neglect this. Plus 5x minus x minus 5 equals 0. If I group this together, what is common here? X into bracket x plus 5 minus 1 into bracket x plus 5 equals 0. Because minus and plus is 1. So that means we are having x minus 1 and x plus 5 equals 0. Definitely we are having s equals to 1 or s equals to minus 5. Now that we have this, do not forget to say find the point on the curve. So that means we are not stopping here. So when x, I told you point is talking about the x and y. So when x equals to 1, we are going to get the y. We're going to get the y here back. What will be y? Y equals to 1 raised to power 3 plus 6, 1 raised to power 2 minus 15, 1 plus 1. That is y equals to 1 plus 1 raised to power 2, 1 times 6, 6. Minus 15 times 1 is minus 15 plus 1. Y equals to 1 plus 6, 7. 7 plus 1, 8. And 8 minus 15, that is minus 7. That means when s is 1, coordinate point. When s is 1, y is minus 7. That's what I mean by point, coordinate. So, again, when x equals to minus 5, so the y actually will be y equals to minus 5 raised to power 3 plus 6 minus 5 raised to power 2 minus 15 minus 5 plus 1. Y equals to minus 5 raised to power 3. That will be 5 times 5, 25. In fact, that is 1 minus 125. Plus, okay, minus 5 raised to power 2, that is 25. And 25 times 6, 5 times 6, 30, 150. So that will be plus 150. Minus and minus plus 15 times 5. That is 75 plus 1. So the y here is 150 plus 76. 150 plus 76. 6, 7 plus 5, that is 12. 1, that is 226. 226 minus 125. 226 minus 125. That is 101. So that is y equals 101. So that means when x is minus 5, y is 101. So when you get the word point, you're also talking about the coordinates. So when you get the x, you have to get the y. And gradient is talking about how you have to differentiate. Now, after that, we have to talk about the application. Talking about the application of differentiation. We have one called maximum and minimum. Maximum and minimum. Now let me quickly talk about this. When we say maximum and minimum, what does that mean? Now under the maximum and minimum, we have what we call turning point. Now this turning point is what that is divided into two. That's why you have this graph turning. It's what that is divided into two. Turning points can either be maximum or minimum. Now, when you see this graph coming up like this, that is maximum. It is maximum here. And how do I know that it's going to be maximum? When the second derivative, d square y all over ds square, is less than 0. It is maximum when the second derivative is less than 0. But it is minimum when the second derivative is greater than 0. That's why it is minimum. What do I mean by second derivative? Assuming you have something like this: 7s cubed plus 2x raised to power 2. Then I say you should find second d square y all over ds square. That's second derivative. It also makes f2. Now, what does that mean? That means you differentiate it first time. This 3 times, that is 21s square plus 4x. That means you now differentiate it once more. That will be 2 times 21, that is 42x plus 4. So that is second derivative. You are differentiating it 2 times. That is what I mean by second derivative. Now, you have to know it is maximum when the second derivative is less than 0. It is minimum when the second derivative is greater than 0. And do not forget, turning point is the one that is divided to the maximum and minimum. And whether it is maximum or minimum, both of them is turning point. And the derivative is turning point when it is dy dx equals to 0. That is turning point. When dy dx equals to 0, dy dx is always equals to 0. That means for you to get maximum, your dy dx must also equals to 0. For you to get minimum, your dy dx must equals to 0. Because both of them are under the turning point. Now you can now start finding your maximum and your minimum. Now let's do some things under this. Let's write some questions under this. You say, at what value of x is the functions s squared plus x plus 1 minimum. Now let's look at this. It said, at what value of x is the function this minimum? Now when you hear the word minimum or maximum, like I told you, is under the turning point. That means the first thing you do is that you divide the x will be equals to 0. Divide the x is going to be equals to 0. Now let's divide the derivative of this now. When you differentiate this, x squared plus x plus 1. Now you might be asking me that I said that for you to get the minimum and maximum, that means we are going to do the second derivative for maximum or minimum. But look at this one. Look at this one. There's no need for doing. I will tell you why you can do the second derivative. Now, if I differentiate this now, when I differentiate this, differentiation of x squared, that is 2x. Differentiation of x, that is 1, equals 0. Now, I can get x straight now. I can say 2x equals to minus 1, all over 2, all over 2. S equals to minus 1, all over 2. That means it is minimum when x equals to minus 1 over 2. Assuming I got two values of x. Now, listen to this thing. Assuming I got two values for x, and they're asking that what values of x, that means I'm going to subject those two values to second derivative to know at what value of x that function is minimum. Already they've told me that this thing is minimum. They just asked me to find the x value at which it is minimum. And that's the turning point. Just differentiate it and equate it to 0. And I got one value for x. That means at this value of x, it is minimum. I don't need to go and be checking under the second derivative. Now let's continue and see what I'm talking about. And the second question here. Look at this also. It says at what? At what value of x is a function y equals to x squared minus 2x minus 3 minimum. Here also we don't need to stress ourselves. That means your divide x always equals to 0 at either minimum or maximum. So that means differentiate this. That is 2x minus 2. This one is 0 equals 0. But divide x is always equals to 0. That means 2x equals to 2. All over 2, all over 2. It is minimum at x equals to 1. They've told me before. Don't need to go and check. Now let me give you a situation whereby you got the two values for x. Two values for x. This one is just one values. Now let's take a look at this. For what value? For what value of x will a function the functions f of s equals to s cubed minus 6s squared plus 5 half turning point. Half turning point. Now let's look at this together. For what value of x will a function of f of x have turning point? I've told you. Turning point is divide x equals 0. Now let's differentiate this. dx, differentiation of this. Let me write it here. Of s cubed minus 6s squared plus 5. If I differentiate this, what differentiation of s cubed, that is 3s squared, minus differentiation of 6s squared, that is 12x. This one is 0. That is equals to 0. Why the s must be 0? I can do this. What is common here? 3x. 3x is common into bracket x minus 4 equals 0. That means 3x equals 0. That's over 3 over 3. Our x 0 divided by 3 is 0. Our s is 0. And our s can also be x minus 4 equals 0. S equals to 4. Now, in this case, we got two answers. We got s equals to 4. We got s equals to 0. But do not forget, we can do the same turning point. So, in case when you now arrive at two values of x, you can know when it is maximum or when it is minimum. Now, I got s is 0 and 4. Now, let me now show you. If they now ask you that at what value of x it is minimum or at what value of x it is maximum, now that means I'm going to differentiate it in two times, second derivative. Now, the first derivative gives me this 3s squared minus 12x. It gives me this. That's the first derivative. So the second derivative, this square y all over the s squared, it's going to give me, if I differentiate this now, 3s squared. If I differentiate it, that will give me 6x minus, if I differentiate this now, minus 4. Give me this. That's the second derivative. Now, if I substitute s, which is 4, in the second derivative, that will be 6, 4 minus 12. 6 times 4, 24 minus 12. 24 minus 12 is 12. Now, is 12 greater than 0? Because if d square y all over ds squared is greater than 0, or d square y all over ds squared is less than 0, you know, let me show you that graph back. The graph is like this. This at maximum, this maximum, and at maximum, second derivative dy squared over ds squared, it is less than 0. But at minimum, the d square y all over ds squared, it is greater than 0. Now, the answer I got here, when I use 4, it is greater than 0. That means at s equals to 4, since it is greater than 0, when I substitute it in second derivative, it's greater than 0. That means at s equals to 4, it is minimum. It is minimum. Now, let me substitute the second answer, which is 0, into second derivative. I want to substitute 0 into second derivative. That will be 6, open bracket, 0 minus 12. Now, 6 times 0 is 0 minus 12. That is minus 12. Can you see? Minus 12, it is less than 0. Now, if it is less than 0, so it has the maximum. That means at s equals to 0, it has the maximum. That means at maximum, s equals to 0. At minimum, s equals to 4. So that is actually what I'm talking about. Let me just do one more, and in the next class we'll continue. Let me do one more to bring clarification to this. So find the value of x, or find the value of x for which the function y equals to s cubed minus x as a minimum value. Now, we'll do this one, we'll stop for today. Now, it says, find the value of x for which the function y equals s cubed minus x as a minimum value. Now, before you check for minimum, I told you it's always turning point. The y ds must firstly equals to 0. That means if I differentiate this, 3s squared, that means you use this power to multiply this 3x, you subtract 1 from the power, that's 2. Minus what differentiation of x? Y equals to 0, because the y dx equals to 0 at turning point. That's the first thing. Whether maximum or minimum, you must do the turning point first. And it's always equals to 0. Now, can we now factorize this? You can do 3s squared equals to, when we bring minus 1 here, 1. All over 3, all over 3. S squared equals to 1 all over 3. If I square root the both sides, it will be like this. Don't forget that this one will be plus or minus. That means S equals to plus root 1 all over 3 or minus root 1 all over 3. Which is the same thing as, you can say, root 1 all over root 3 or minus root 1 all over root 3. Which root 1 can also be 1 all over root 3 or minus 1 all over root 3. I'm still talking about the same thing. Now, but they ask us that they don't say we should just stop at x. They say find the value of x for which the function this has a minimum value. Has a minimum value. Now, for us to know, is it here it is minimum or maximum, or here it is minimum or maximum? We're going to go back to our stuff. And our stuff say that it is, when you draw the graph, this is maximum. And this square y all over ds squared, it is less than 0 at maximum. But this minimum, this square y all over ds squared, it is greater than 0 at minimum. And you have to differentiate it once again. You have to differentiate it once again. Now let me find the second derivative. Now I got plus root 1 over 3 s equals or minus root 1 over 3. Those are the two values of x I got. Now let me now differentiate it once more. The question originally, it is y equals to s cubed minus x. And when we firstly differentiated it, we have y equals to 3s squared minus 1. Now, for me to get second derivative now, this square y over ds squared is going to be on, I will use these two to multiply this. That will be 6x minus, what's the dimension of 1? 0, which is 6x originally. Now, for me now to know when it is maximum or minimum, they ask me to find when it is minimum. Let me substitute this one first in second derivative. That means 6 into bracket. I told you it can also be what? Root 1 all over root 3. And root 1 is 1 all over root 3. Let me substitute it. 1 all over root 3. So 6 times 1, that is 6 all over root 3. When you rationalize, it will be times root 3 over root 3. That means 6 root 3 all over. Root 3 times root 3, root 9. And root 9 is 3. 3 cancel 3, that is 2. That is 2 root 3. Now let me ask you, is 2 root 3 greater than 0 or less than 0? It is actually greater than 0. That means for 2 root 3 to be greater than 0, that means it is minimum. It is minimum at, x equals to plus root 1 all over 3. Or in case of our options, you can also see that like s equals to 1 all over root 3. Or when they rationalize it, or root 3 all over 3, when you rationalize it. So that, because they asked us to find the minimum. Definitely, if I check for the second one, it's going to be the maximum. So I'll stop here for today. Please do this channel a favor by subscribing, like, and share. Thank you so much.